all of exploration in the universe, we have three fundamental questions. First, are we alone? Second, is there habitable worlds elsewhere? And third, if there are habitable worlds and we keep looking for life elsewhere, when will we find life? I do believe that life exists elsewhere. And so when will we find life and what type of life forms? So I love to think of living in balance with nature. And for me, it actually then becomes historical. And I go back to the ancient wisdoms and ancient philosophies of civilizations and civilizations of our elders and First Nations folks, people who live on islands who know how to live exactly in balance with nature. They have limited resources, and it's very circular. It's very circular. There's enough to eat, taking care of nature. Nature will provide. But I think we have to get back to that mindset of living in balance with nature. 70% of the world now lives in urban environments, do live close to the oceans, but the pace, the frenzy of our urban environments and our consumption and that mentality, I think we need to get away from and just think about what makes you happy. Being happy every day, living in balance with nature, and being with other people and living things. So we've been exploring Mars for 50 years with our scientific experiments and our space science, and now living on Mars with our rovers. But the big goal is a human mission to Mars. Why? Because we're looking for the evidence of past life. We're searching for life in the universe, and Mars is a sister planet to Earth. We share the same 4.5 billion year old history in our solar system, and life worked out pretty well here on Earth. And Mars, we think, probably could have had life 3.5 billion years ago. It lost its dynamo, its electromagnetism as a planet, and now Mars is left with 1% carbon dioxide atmosphere today. So that's how Mars is today. But we're studying its entire history and looking probably like for past life, fossilized life forms. We know there's water on Mars today. We only thought there was ice previously in the North and South Pole. Now we know that there's actually water. You can't drink it. It would kill you, too high in acidity. But we're looking for the chemistry, if you will, of life. So we have water, right? We have hydrogen, we have oxygen. It's a carbon dioxide atmosphere. We have methane. So those are all the building blocks for life. And I think life wants to exist. For a human mission to Mars, the biggest technological challenges are first, you need heavy lift launch. And we haven't had heavy lift launch since the Apollo program, and now we're back. Now we have the Space Launch System, and also SpaceX is developing heavy lift launch and Blue Origin. So we are in a different place with all of space exploration and the really exciting public-private partnerships. Now still to get to Mars is very hard. So we're going to go to the moon next, and we'll go there in the coming years, just in a few years. But I think in the coming decade, we'll get humans to Mars. Besides the heavy lift launch, we need complete life support systems. I need to design you a spacesuit. Moon is a vacuum, so I have to provide all of your oxygen. I have to provide your pressure, and we do it through kind of transformative technology, revolutionary technology called mechanical counterpressure, or the biosuit. It pressurizes you, kind of shrink wrap you. We call it a second skin suit. It's very different than the traditional gas pressurized 160 kilo suit that's very heavy. You can't be an Olympic athlete in this big heavy suit. It's a wonderful engineering marvel. It's like taking a spacecraft and shrinking it around you and giving you all of the life support you need. Oxygen, scrub your carbon dioxide. However, we flipped the design paradigm and started designing a spacesuit from the skin out so that we could have very mobile, a lightweight suit, it's like making someone an Olympic athlete rather than being constrained, in a spacecraft. So we kind of flipped that in the suit. So all of that technology has to be tested. It has to be flight qualified so that we can really enable exploration. And then we also need to think about how we're going to, I call it, live off the land. On the moon, there's a lot of basalt, but where are you going to live? What about your shelters? We could go underground and live in lava caves. We need to develop habitats and rovers, pressurized rovers, to keep our astronauts alive. Now that technology, once we understand it and once we've tested it, then we can kind of pay it forward to Mars. So those are the technologies that we need to understand, and we need those technologies then for a human mission to Mars. So that's why the moon is a great next step, kind of a stepping stone, we call it. But for the search for life, we need to get out to Mars. We have robotic missions, which are fantastic. They're wonderful. The MIT experiment on Mars today is called MOXIE. We're making oxygen literally on Mars by taking the carbon dioxide atmosphere, ablate the carbon atoms, separate that, get the elemental oxygen, recombine it for O2. So we're making oxygen on Mars. And so these are precursor technology demonstrations to prepare for a future Mars mission with humans. To really understand the environment, to imagine ourselves there, we can do that through some technology. I use a lot of augmented reality, transport people with real Mars images. And then what's it going to sound like? That's what people are curious. So people want to know, what's it going to sound like? What's it going to be like? And so we run simulations, literal digital simulations with real audio sounds. Say, well, this is what the rover sounds like. Oh, this is what our instruments, I show an audio file from a laser. Tap, tap, tap. This is what it sounds like. And then I like to show people and present the sound of wind, because everybody knows that it's windy on Mars. But with that 1% carbon dioxide atmosphere, such a low atmosphere, it's nothing like the wind on Earth. There's no hurricanes. It's always windy on Mars, but it's very light wind, and it would feel like a little feather brushing against your face. So it's always windy, but very light wind. So not hurricane force winds, just a light wind. And so always want to have a camera with you. You always want to have a microphone with you, because that's, I think, how people can relate and they can see themselves and also understand, the data, the scientific exploration that we're doing, kind of bringing people, literally onto the planet with us. We want to bring all the kids in the world with me, even though physically it'll be a few Martian explorers. What I want to do is bring all the kids that want to go on that incredible journey with us. I think we will have humans on Mars, the first Martian explorers, in the coming decade, meaning the 2030s, by the end of the 2030s for certain. And that builds on our 50 years of robotic and scientific exploration on Mars today. We have orbiting science missions. We have landing missions. We're actually analyzing what Mars is made out of, the chemistry. We need a sample return mission. We're caching the samples today on our Perseverance rover, but we need to bring those back to Earth. So it's all a long, continuous, decades-long plan for exploration and culminating in humans to Mars. Hopefully in the 2030s, it'll be now humanity and humans, global international crews going to the moon. And we do need about a decade on the moon to advance our technologies. Moon is 3 days away trip, and it's round trip, so you can test the technologies, you can learn about building and habitats, keeping your people alive. One huge challenge for a human mission to the moon or Mars is the radiation environment. So again, we're inventing new materials, new technologies, new materials inside the suit to help with radiation protection. So this is all the research that we're working on. So a good decade on the moon to test our technologies, invent new things that we need, get the heavy lift launch, and then the 2030s, I see it, that we get humanity to Mars, and again, focus on the science of looking for the evidence of life, past life, or the current building blocks and chemistry for current life, but probably past life. And this round trip, of course, we bring the astronauts back home to everyone they love here on Earth, which is our most important planet. So I like to speak about Earth's vital signs from our scientific data. This is our Earth-observing satellites, eyes on Earth, as well as tens of thousands of sensors on the ground and even flying aircraft. So we have a rich data set from satellite imagery looking down at Earth, atmospheric data, and then sensors, Internet of Things in the oceans, on land. And so we take all that data, right? That scientific data we're measuring, monitoring daily. And when it comes to the Arctic, the Greenland ice sheet, and Antarctica, the Antarctic ice sheet, those two ice sheets, those glaciers, if you will, those ice sheets hold 99% of the world's fresh water. Now it's trapped in ice, and they're melting. And so we are measuring those. We have very specific satellites called ISAT-2, a polar orbiter, always measuring and monitoring the land ice and then the sea ice. Because as we have the sea ice in both Greenland and Antarctica, our glaciers are melting, is calving off to icebergs. And so we really need to know how much ice are we losing from Iceland and from Antarctica. And it's critically important because that causes sea level rise. And we already have sea level rise. But if the Greenland ice sheet melts entirely, it's melting much faster than even our models. If it melts entirely, that will be 6 meters of sea level rise for the world. Can you imagine? I can't imagine. So we have to prevent that. Antarctica is, covered in ice. The entire continent is over 3,000 meters of ice. So if Antarctica is melting, on the sides where the interface is with the oceans and the icebergs, but all of that trapped fresh water in Antarctica, if that melted, that would be 60 meters of sea level rise. So that's not the future that is optimistic and that we envision. So we want people to understand this, to change behavior and live in balance with all nature so that all living things can thrive, our oceans, our biodiversity, and humanity here on Earth. So we have to get this right. I really want the world to work for 100% of humanity and all living beings. That's a big, bold ask. It's from Bucky Feller. That's his philosophy. And so I'm going to have a scientist and engineer working with a team of designers and artists, performers, you name it. And we're focused on that. How do we have the world work for 100% of humanity? I think we can realize it. And that's, to me, not just a beautiful dream. I'm also very fond of a quote by Eleanor Roosevelt. Believe in the beauty of your dreams. So for me, if I can dream it, if I can see the world working for 100% of humanity, then we can become that.